So let's take a look at some real-world applications dealing with the normal distribution. In this example, the U.S. Navy requires that their fighter pilots have heights between 62 inches and 78 inches. And there are really some good reasons for why they require that their pilots be between 62 and 78 inches. It has a lot to do with their airplanes and to deal with safety and efficiency. So we're going to take a look at women's heights, and we know that women's heights is normally distributed with a population mean of 63.7 inches and a population standard deviation of 2.9 inches. So anytime that you know you have data that's normally distributed, go ahead and draw yourself that bell-shaped curve, identify the mean for the distribution, and then go ahead and label, so in this example, label the heights that are 1, 2, and 3 standard deviations from the mean. So we're using a standard deviation of 2.9 inches. So you can see here I've already done that. And below those heights, I've written down the corresponding z-scores. We want to answer the question, find the percentage of women who meet this height requirement. So the percentage of women who meet this height requirement, I can find that by finding the probability that a randomly selected height from this distribution is going to be between 62 and 78 inches. So to answer this question, I'm looking for the area under the curve between 62 and 78 inches. So in red here, I'm going to mark where 62 is on my distribution, and it's probably somewhere around there, okay? And then 78 is probably closer to being off to the right-hand side, somewhere over here. So the percentage of women who meet this height requirement is going to equal the area of the red shaded region. So let me shade in the area under the curve that is between 62 and 78 inches. So now how do we find areas under the curve when we have known values? If you're using your graphing calculator, so I'll make a note down here. Oops, let me use my pen, not my highlighter. If you're using your graphing calculator, we're going to use that function second bars, which is going to take you to your distribution, and we're going to choose normal CDF. So here we would use normal CDF, and normal CDF is going to ask you to put in your lower limit and then your upper limit. So in this particular problem, the lower limit is going to be 62, so that's going to be the lower limit, and the upper limit is going to be 78. Okay, so you're going to type in 62 to 78, and then you're going to type in the population mean, which is 63.7. So that represents the population mean. And then you're going to type in the population standard deviation, which is 2.9. So that's sigma. And then that 78 is your upper limit. And when you press enter, your calculator will give you 0.7211. So that tells us that approximately 72.11% of females, right, would qualify to be a fighter pilot for the U.S. Navy. Now, if you're using the z-table, then what you would need to do to use the z-table is you would have to take 62 inches and convert that to a z-score. So to find that z-score is x minus mu. So mu here is 63.7. And divide that by sigma, which is 2.9, that's going to give us a z-score of negative 0.59. So that 62 has a z-score of negative 0.59. And then when you go to the z-table, if you search on the negative side of the z-table, it will give you the area that's to the left of that z value. So the area to the left, I'll shade in green here. Okay, so that area to the left, you'll get this area from the table. So from the z-table, you'll see that the area to the left is an area of 0.2776. So if we want to find the area that is in red, to find the area that is in red, you would have to take 1 and subtract 0.2776, and that will give us 0.7224, which hopefully you can see is very close to what we got from using the calculator. Now, the reason for any differences if you're using the z-table versus the calculator, it's all due to rounding, because remember when we calculated that z-score, we already rounded that, and so it's just due to some rounding errors. Using the same example, this time we want to take a look at if the Navy changes the height requirement so that all women are eligible except for the shortest 3% and the tallest 3%, what would the new height requirements be for women? Now, recall that the current height requirement is that women be between, or that their fighter pilots be between 62 inches and 78 inches. Okay, so again, we know that women's height is normally distributed with a mean of 63.7 inches and a standard deviation of 2.9. So knowing that the data is normally distributed, we draw ourselves a bell-shaped curve, and then we label the heights that are 1, 2, and 3 standard deviations from the center. And then right below that, you'll see that I've written down the corresponding z-scores. So to answer this question, let's highlight in the bell-shaped distribution here what an area of 3% would look like on the lower tail and the upper tail. So I'm going to, let's see if I can very carefully mark off 3% here. So 3% is probably something close to like here, okay? And then I'm going to mark it in the same, approximately same spot on the right side, okay? So the red shaded region that I am shading on the left here represents the shortest 3%, so I'm going to write that percent as a decimal. And then the red shaded region on the right here represents the tallest 3%, so tallest 3%. So if I want to know what height corresponds with separating the bottom 3%, I'm going to use blue here, I'm looking for that height right there. And then the height that separates the tallest 3% would be the height that's the question mark that I've drawn on the right-hand side there. So what we're going to do here is we're going to either use our calculator or use the z-table. So if you're using the z-table, I'm going to start with this question mark here. So I'm going to start with that height. To find that z-score, or to find that height, I'm going to first try to find the z-score. And then once I know the z-score, I can translate that to the height. Okay, so according to my drawing here, it looks like it's going to be between -1 and -2, but let's say you didn't know that it was between -1 and -2. How can you still use the z-table to find that z-score? Well, you're going to focus on the area to the left here. So we're looking for an area of 0.03, and because it's on the left tail, I'm going to go to the negative side of my z-table. And notice here, I'm searching for where on the table do I see an area of 0.03, and so I see it down on the corner here, and that corresponds to a z-score of -1.88. So that tells me that the z-score is -1.88, and now that I have the z-score, I can use that formula, x equals z times sigma plus mu, to then find the height that corresponds to a z-score of -1.88. So that height is going to be -1.88 times sigma, which is 2.9, plus mu, which is 63.7. And so that means that a height of 58.25 inches is the height that separates the lowest or the shortest 3% of female. So then that means that they're changing the height requirement from 62 inches to 58.25 inches. And then to find the height that corresponds to the tallest 3%, well, because this is a bell-shaped curve that is symmetrical along the center there, we know that since the area on both tails have the same area, they're both 0.03, that means that the z-score that corresponds to this height on the right tail is going to be positive 1.88. So now if I use the formula for calculating that x value, I'm going to use positive 1.88 times 2.9 plus 63.7, and then that's going to give me 69.15 inches. So then that changes the new height requirement from 78 inches to 69.15 inches. If you're using your calculator, then you're going to choose second bars, which is going to take you to the distributions. And then here you're going to want to use inverse norm. So the first thing that I'm going to do is try to find the height requirement that separates the lowest or the shortest 3% of females. So notice the area that I'm typing in is 0.03. And then I'm putting in the population mean and population standard deviation for women's height, which is 63.7 and 2.9 respectively. And then you can see here when you press enter, the calculator gives you 58.25 inches, which is what we got when we used the Z table. And then you would repeat this process to find the height that separates the tallest 3% of female. And I don't have a screenshot of that here, but once you use inverse norm, right, this time to get the height that separates the tallest 3%, I would type in 1 minus 0.03, okay, and then type in 63.7 comma 2.9, and then when you press enter, it'll give you 69.15 inches, okay.